Hey everyone, Mr. Shatter here to begin the conversation about the chain rule. Now before we can talk about the chain rule, we first have to examine the different layers of complex functions. Only then can we start to take their derivatives. Just like ogres and onions, the chain rule has layers. Understanding the layers of each problem will help you differentiate. For example, a problem that contains just one layer is the square root of x. Notice that inside the square root function is just a singular x. Compare that to the square root of 3x plus 2. The square root of 3x plus 2 is now considered a multi-layered function because the first layer is the square root and the second layer is the binomial 3x plus 2. Another example, one layer sine x, multi-layers sine 3x. So instead of now just being sine of a singular angle x, we're now plugging in 3x into the angle. One last example. Just one layer is a cubic polynomial here, 4x cubed minus 3x squared plus 2x, whereas a multi-layered function would be that cubic polynomial all raised to the second power. Layers are essentially the composition of functions. Take that previous example for a second, f of x equals the cubic polynomial squared. The initial layer of this function is basically something being squared. Right? That's the first layer in here, something squared. And then the innermost layer is whatever that term is, or in this case the cubic polynomial, actually being raised to the third power. So this would be our second layer, this cubic polynomial. So if we were to allow x squared to be considered as, let's say, g of x, and the cubic polynomial we'll call h of x, to get the original function f, you're basically composing g of h of x. You're taking h of x, which is this cubic polynomial, and you're plugging it inside of g, which is this x to the second term, this right here. So the function f is really just the composition of g of h of x. H of x goes inside g of x. So this problem says, what are the different layers of the function below? So the function is y equals 3 times sine cubed of 4x. Well, the first thing I'm going to do before solving this problem is take the cube and pull it out to the end of the function. So I'm going to rewrite this thing as 3 times sine of 4x quantity cubed. Okay? So if I examine the layers here, the first layer is essentially 3 times something, which I'll just place an x in there for now, cubed. The first layer of this is 3x cubed, right? Where the x in this case is basically a variable taking the place of the sine of 4x. All right? If I then dig a little deeper, the next layer is this layer right here, which is the sine 4x, this piece. So you have to remember, though, that sine of 4x is actually a two-layer function, because the outermost layer of sine of 4x, so if I just write it right here, sine of 4x, the outermost layer is actually just the sine of x, right? Sine of x. And then the innermost layer of that is this angle here. What is the angle in this problem? It's actually 4x. So this is a three-layer function. Layer number 1 is 3 times something cubed. Layer number 2 is the sine of something. And layer number 3 is that innermost piece, the 4x that was the angle of the sine function.